Do today is use matrices to model networks. And here's an example of a network. And a network is simply a bunch of different locations that may or may not have connections between them. So I've got these four locations here, N1, N2, N3, and N4. And there are connections between some of them, and there are not connections between others of them. And do you realize that all this is a graph? This is a kind of a graph. It's just not an XY coordinate graph like you're used to. This is a different kind of a graph. So what we do is we list N1, N2, N3, and N4 along the left-hand side and across the top. And in every single space in our matrix is either a connection or not. So if I go to this point right here, it means, is there a connection between N1 and N4? Because it goes to N1 and N4. Now if I look at N1 and N4, there is no direct connection between them, correct? So it gets a 0. Okay? But if you go over here to this one, it goes between N1 and N3, right? So here's N1 and N3. Is there a direct connection? Yes, there is. So I'm going to put a 1 there. All right, so that's all I'm doing. Now notice this. If I go down here, this is also N3 and N1, right? It's like a repeater. So again, a 1 goes there. So all you have to do to fill in your matrix is look at your picture and try to figure out, is there a connection between those two locations? You put a 0 if there's no connection and a 1 if there is a connection. Okay? And that's it. That's all we do in this matrix. What I want to show you next is actually a directed matrix. And this is a matrix that has arrows on it. So if we go down to this picture at the bottom of the page, you can see these are a bunch of streets. And some of them are two-way streets and some of them are one-way streets, right? And so here are locations. There's a fire department here and a school and an apartment building and a hospital, right? All these things are right here. Now, if you look at the roads, there's a two-way street between the fire department and the hospital, and a one-way street between the fire department and the apartment building. All right, so different all over the place. If we want to make a matrix to show this, all we got to do is we'll give ourselves some labels here. So I'm going to label, I want to label this QST. All right, I'm going to call this P, call this Q, and I want to call this S and T. I'm just giving them variable names. You can name them whatever you want, and I'm just doing that for the sake of making my P, Q, S, T across the top, P, Q, S, T along the left-hand side, right? Now, there's something that's different about this one. Do you see how this one had arrows and the one up here didn't have arrows? This is not directed, this is directed. So, when you put your zeros and your ones, the question is, this right here is the from, and up here is the to. So, for example, is there a route from P to P? Now, I will tell you, if you wanted a route from P to P, it would look like this. That's a route from P to P. It's a loop right around back onto itself. We don't have any of those. So this is going to be a 0. Is there a route from P to Q? Yes, there's an arrow going from P to Q, so we're going to put a 1. Is there a route from P to S? So here's P, and there is an arrow that will take you to S. So we're going to put a 1 there. Is there a route from P to T? There is a route from P to T. Okay, Go down a row. From Q to P, is there a row? So here's Q, here's P. And since this is a two-way row, there is a row. So we're going to put a 1. From Q to Q, we don't have any of these, so we're putting a 0. In fact, we don't have any of those, so S to S is a 0, and T to T is also a 0, okay? You'll see in a minute there's an example that has one of those in it. All right, from Q to S, so here's Q, here's S, nothing, right? Okay, 0. From Q to T, from Q to T, is there a route? No, because there's no arrow going that way. From S to P, is there a route? Yes. So a 1. From S to Q? No. So it's a 0. From S to T? Yes. So it's a 1. From T to P?
No. Yes. No, it's one way.
T to P, it's one way. From T to Q? Yes. From T to S? Okay, so that is what your matrix representing this directed graph would look like. Pretty cool? We're going to go backwards here. Here is a cute little matrix. And what we're going to do with this matrix is we are going to make a directed graph to show the picture that would go along with this matrix. So notice I have an A, a B, and a C, right? So just make 3 points. It doesn't matter where you put them. Would you agree it kind of gives you a triangle shape to it, right? Okay. From A to A, we have a 1. So you're going to have one of these. All right? From A to B, so put an arrow going from A to B. From A to C, so put an arrow going from A to C. From B to A, so now I'm going to have the arrow going both ways because I got to put it that way. Nothing between B to B, and a 1 going from B to C. So there we have that. And C doesn't go to anything. So that you only are going to draw an arrow anywhere that you see a 1. This is all zeros, so that's it. That's all we got.
Oh my gosh. Is that it for notes?
That is it for notes.
Love that.